Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the January 2024 International A-Level Edexcel Statistics S1 exam. This question here is about, it looks like normal distribution. It says the distance an athlete can throw a discus is normally distributed with a mean 40 meters and a standard deviation 4 meters. Using standardization, show that the probability that this athlete throws the discus less than 38.8 meters is 0.3821. Okay, so these questions can be answered on calculators. Now, I don't really teach that in these lessons, on these videos, because there's different calculators that you have to be used in different ways, okay, and that's one reason. So I might make a video and then somebody else has got a different type of calculator and they get confused how to deal with it with their calculator. Secondly, as the question says, they're using standardization. So basically, they want you to show a certain amount of steps, okay, which make them realize that you know how to deal with this and what the principles are behind this without just putting some values in your calculator, right? So you should understand how to deal with this question without having to resort to your calculator solely, without understanding, some people can do the questions like this without really understanding what's going on, just put the numbers in, not understand anything about the symmetry of the normal distribution curve. They want you to have some sort of understanding of that, okay? So basically, what we're going to do is I'm going to show you how to do this using standardization. So basically what it is we have a table of values like this. These ones above here, this one's below there. They're both table of values, which are values based upon the normal distribution that looks like this, where the mean is 0 and the standard deviation is 1. The mean is 0 and the standard deviation is 1. So what we're going to do is we're going to take these values here and we're going to standardize them, okay? So when I say the mean is 0 and the standard deviation is 1, basically, what it basically means is we're going to find out for this information that we have for this normal distribution, okay, how many standard deviations above or below the mean this particular amount is. Of course, we can see it's going to be below the mean, but we want to find how many standard deviations below the mean it's going to be. And we can do that using the formula of standardization, which is Z equals X minus the mean over the standard deviation. Okay, so X is the amount that the value you're trying to standardize, mu is the mean, and sigma is the standard deviation. So here they told us the distance is such that it's normally distributed with a mean of 40 and a standard deviation as 4. Over here, we always write the variance. I'll put 4 squared. The variance is the square of the standard deviation. Okay, so this is just writing this information in the format of normal distribution, which we should know because sometimes they give us this in this format. We should understand this is not the standard deviation, this is the variance. The variance is the square root of that. Okay, so if I want to standardize the 38.8 meters, I can use this formula. So I want to find the probability that the distance thrown is less than 38.8, okay, which is going to be the same as the probability that Z is less than, and now I'm going to standardize the score by putting it into this formula. So the X is the value you're standardizing, the mu is the mean, which is 40, and the sigma is the standard deviation, which is 4. Okay, we use the standard deviation, not the variance. Okay, so this will give us the probability that Z is less than. If we put that into our calculator, we have 38.8 minus 40 divided by 4. That gives us negative 0.3. So negative 0.3. So we want to show that the probability of this is equal to 0.3821. So we're going to use our normal distribution curve. Now we know that the Z value is negative 0.3. So the negative Z value start from the left of this. So this is the Z value, which corresponds to negative 0.3. And we want to find this area which is to the left of it. That's what we want to find. that area is what we're looking for, and we have to show that that's equal to this amount. Okay, so that's what we have to find. Okay, how do we find that area? Well, if we go to the normal distribution, okay, first of all, the Z value we're using is not one of the Z values that are in this table here, and the area that we have to prove is not here either. So we have to use the table, which is the big table, okay? And the big table, basically, this is the Z value, okay, which is along this axis. And this is the area to the left of that Z value under the curve. That's what phi Z means. Okay, so for example, when Z is 0, we're right in the middle here. That's when Z is 0. And this 0.5 means it's the area to the left of it, which is 0.5, meaning half of the whole area. The whole area is always going to be 1. Okay, so if we have, for example, Z equals 1.03, that's going to be somewhere over here, for example, 1.03. And the area there, which is 0.8485, is all of this area to the left of it. That's why it's going to be like bigger than 0.5, 0.5, and it's going to, and more, basically. All right, so that's what this graph or this represents. So what we're looking for is Z equals negative 0.3. Now, what you'll notice is we don't have any negative Z values. They're all positive. Okay, so we can't find Z negative 0.3. That's over here. We can't find it directly from the table. It doesn't exist on the table. What we have to do is we have to go to the other side where Z is positive 0.3. Okay, and we have to realize that it's not drawn that well, but we have to realize that there's some sort of symmetry here. That this area that we're looking for, which is this over here, will be the same area as this area, which we we can't find directly from the table, but we need to find this. This area is the same as that area. What the table does tell us, if I go to 0.3, it tells us the area to the left of this. It tells us all of this area over here. And the total area is 1. So if we do 1 minus this area here, okay, we will end up with the area that we're looking for. Because the whole thing minus this part leaves us with that part, which is exactly what we're trying to find. So basically what we need to do is we need to go to 0.3. That's all. So we go to Z equals 0.3. Okay, can we find it here? It's down here somewhere. Z equals 0.3. Here it is. So we take Z equals 0.3. I'll just copy it across in case I get the numbers. Okay, and we're going to use that over here. Scale it down a bit, it's just too big. So Z equals 0.3 is going to, as I mentioned, it's going to be the same value, but on the other side. Let's try and do this like that. Okay, so it's going to be 0.3, not negative 0.3. And this area that we've got here is the area to the left of it. Okay, so it's the area to the left of it. So you could say it's this area from here all the way across. Oops, that's a bit big. It's this area all the way down to here. Okay, that's the area that we're going to get. So the area that we're looking for is going to be 1 minus this area. 1 minus 0.6179. So what we can say, if we want to write our steps nice and neatly, is we can say that this is the same as a probability that Z is greater than 0.3, okay, which is this area over here, okay, which is equal to 1 minus the probability that Z is less than 0.3. Why do we have to do that? Because that's what the table tells us. It doesn't tell us that. Okay, so that's 1 minus the probability that Z is less than 0.3, which is 0.6179. And hopefully that will be exactly what we have to show. So we're going to have 1 minus 0.6179, which gives us 0.3821. 0.3821. So that's a probability that Z is, or that's a probability that D, it's a probability that D is less than 38.8. Okay, so that's the answer to part A. Okay, so yeah, so that's the answer to part A. Now I'm going to go into part B. Part B, I've got it ready on the next page, so let me sort that out. Okay, so I think we're going to need what we just did, that the probability that the D is less than 38.8 meters is equal to 0.321. And we also need that probability that D is greater than 38.8 meters is equal to 0.6, sorry, 0.6179. 0.6179. Okay, so those we will need, I think, for this question. So it says this athlete enters a discus competition. To qualify for the final, they have 3 attempts to throw the discus a distance of more than 38.8 meters. Once they qualify, they do not use any of the remaining attempts. So basically, if they throw with their first throw something which is more than 38.8 meters, they've qualified, they don't do a second throw, they don't do a third throw. If they fail to get to qualify on the first throw, and on the second throw they throw more than 38.8 meters, that's it. They've qualified. They don't do a third throw. If they fail on the first and the second throws, they get less than 38.8 meters in the first, second throw. They have a third throw. If they fail again, they won't qualify. If they get the throw on the third throw, they've qualified. And of course, there won't be any more throws because there's only 3 throws. Okay. So once they qualify, they do not use any of the remaining attempts. That's what that means. Given that, and this is a very, very important statement when they have probability type of questions, given that they qualified for the final, so given that they qualified, that is like the conditional. That's like the sample space. So we're only now considering the probability of them qualifying as our kind of sample space, that they qualified, okay? And that the throws are independent, meaning, if they fail on the first throw, it doesn't affect the probability of failing or passing on the second throw. They're independent of each other. Each throw has the same probability for every attempt. Find the probability that this athlete qualified for the final on their second throw with a distance of more than 44 meters. Okay, so you need to read the whole question carefully. With a distance of more than 44 meters. All right, so we need to basically, if we look at the whole or the big picture here, we want to find the probability that they qualified with a throw of greater than 44 meters on their second throw, given that they qualified. Okay, so they qualified on the second throw with a throw which is greater than 44 meters, given that they qualified. Okay, so first of all, let's deal with the probability of them qualifying. Let's look at all the different ways that someone can qualify, and that will be our denominator, that will be our sample space, because we know that the probability of A given B is the probability of A intersection B over the probability of B. So the probability of B here would be the probability of qualifying. So we got to find all the different ways that someone could qualify for this competition. So there's 3 different scenarios. We have throw 1, throw 2, throw 3. Okay, so the first scenario would be that they qualify on the first throw. So the first throw, we find the probability that the distance they throwed is more than 38.8 meters. Okay, let me just make some space here. Okay, more than 38.8 meters, which would mean that they do not require a second throw and a third throw. They won't do the second and third throw if that's the case, right? So that is basically just the probability of throwing more than 38.8, which is 0.6179. That's 0.6179. Okay, that's one scenario, but that's not the only way someone can qualify. They could, on their first throw, the second scenario is that they could get less than 38.8 on the first row, which means they wouldn't qualify in the first row. So less than 38.8, the first row, and the second throw they can get more than 38.8. In which case they would qualify without having to do the third throw. There will be no third throw. So that would be 0.3821 multiplied by 0.6179. Okay, less than, and then the second throw would be more than the qualifying distance. And the third scenario would be the probability that they missed, they didn't qualify, so 38.8, and then they didn't qualify again, The second throw, 38.8. But on the final throw, they managed to qualify. So now this is part of our sample space of qualification. So you're going to have 0.3821 twice. So that's going to be squared. That times itself. Then the final throw, 0.6179, where they qualify. So we can say the probability of qualifying, therefore, is going to be the sum of all these things together. We have to add them all together. Okay, so we have to find the sum of those. So let's do that. So we have 0.6179 plus we have 0.6179 times 0.3821 plus and 0.3821 squared. Okay, be careful. 0.3821 squared times, for the final throw, 0.6179. You have to be very careful when you're putting these numbers in because it's very easy to make a mistake. Okay, so that gives us 0.94421, 0.94421. Okay, so I'm not going to round this. In fact, I'm going to store this as A in my calculator. So I'll put a little A here to remind myself that I've stored this value as A. Okay, so now we have find the probability that they qualified. Okay, now that's going to be our denominator. Now we've got to do the second stage. We've got to find that the probability that they qualify with a throw greater than 44 meters. Okay, so we'll find just this part here. Okay, so the throw greater than 44 meters. So how do we find the probability that D is greater than 44? Well, we go back to the same method that we did before. We standardize it. We say that that's the same as the probability that Z is greater than 44 minus the mean, okay, which was, let's go back here. I forgot to write this down. Let's take this and put it here. Okay, so 44 minus the mean, which is 40, over the standard deviation, which is 4. Okay, so that's going to be 4 over 4, which is 1. 4 over 4, so the probability that Z is greater than 1. So we need to find the probability that Z is greater than 1. So let's take this back with us. Okay, so if we take our normal distribution curve, Z is greater than 1 is going to be somewhere, of course, above the mean. Okay, so we're going to find the probability that Z is greater than 1. So we need this area here. Okay, so the probability that Z is greater than 1 is the same as 1 minus the probability that Z is less than 1. Same reason as we mentioned before. Our distribution table and our table gives us what's to the left of this, which is that. Okay, so if we go back to that, we look for 1, Z equals 1. If we look for Z equals 1, we've got it here, 0.8413. 0.8413. Okay, so we've got that there. Keep it smaller. So we have here what we're looking for, 0.8413. So we can say that this is equal to 1 minus 0.8413, which equals 1 minus 0.8413. That gives us 0.1587, 0.1587. So that's a probability that they get more than 44 meters. However, we got to find the probability that they qualify on their second throw, Okay, so that means the first throw, we've got to find the probability that the throw was less than 38.8. And this is, remember, the probability that the distance was greater than 44. Okay, and if they qualified on their second throw, with a throw more than 44 meters, we're going to put the probability that D is greater than 44 in the second throw And of course, there will be no third throw. So this is going to give us 0. Okay, so we have the first, which is 0.3821. Okay, 0.3821 multiplied by 0.1587. Okay, so that's the probability that they qualify on the second throw with a throw more than 44 meters, but we have given that they qualified. Okay, so qualifying is a subset of qualifying, qualifying with a throw of greater than 44 meters is going to be a subset of qualifying. So the intersection of qualifying on the second throw with throw more than 44 meters, okay, intersection with qualifying will be the same as just this. It will be the same as this, which is 0.3821 times 0.1587. Okay, it's going to be a subset of it. So it's going to be the same as this. When something is a subset of something else, the intersection between them is just the one inside. So it's going to be just the one inside, which is what we just found here, divided by the probability that they qualified, which was, we found here, which was 0.94421. So it's not just this on its own. You have to divide it by 0.94421 because there's a conditional probability where the subset or the sample space is the fact that they qualified, not just, the whole thing, whether they qualified or not. It's given that they qualified. So you have to divide it by the probability that someone qualifies. And that will give you the answer. So hopefully this will be the correct answer. So we take this and we have 0.3821. In fact, what did we have before? 1 second. Just get rid of this. Okay, before that. Okay, no problem. We'll just do this. So 0.3821. 0.3821 multiplied by 0.1587 divided by what I called A, okay, which was the value that we had up here. This is the value that we had up here. Okay, so that will give us our answer, which is 0.06422. 0.06422 goes on to 3SF. So the final answer, therefore, rounded to 3SF, 0.0642. 0.0642. And there we have the answer to this question. I hope that was clear. Okay, this was a question which something very similar came up a few years ago. In fact, it seemed almost like the same thing, except that was about javelin. It was almost the same type of question, maybe different numbers, but the same idea, almost exactly. All right, so anyhow, any other questions that you want to see from this paper will be found in the playlist. It will appear at the end of the video in this area of the screen, and you'll have a link to the playlist, which is dealing with normal distribution. In this area, you can subscribe to the channel by clicking on this link, and the video at the top, which is linked, which will tell you how to use my channel in a way that will be easy for you to find what you're looking for. Thank you for watching, and see you soon.